Today we're going to talk about a very special rule that applies to limits, okay? This is pronounced L'Hopital, okay? Can you say it? L'Hopital. Everybody together, ready? Go. L'Hopital. It is, yeah, some people say little hospitals. That's not, no, not. They like to make fun of it. L'Hopital. It's a great rule, but we have to talk about why it comes up. First of all, please cross this off. I made a mistake. It's not +2. I forgot to delete that I was writing a new problem big. We're going to look at a classic example. A for the day. Do you remember what the limit as x goes to 0 sine of x over x is? You learned it. It's 1. Thank you. Very good job. We proved that using the sandwich theorem. Okay? Now, what I want to do is I want to look at this limit. And if right now, if you plug in 0, do you know what the sign of 0 is? 0. And if you plug in 0 for the bottom, you get 0. Now, we're used to situations, if you get 0 on top, the answer is 0. If you get 0 on the bottom, then the answer is undefined. But when you get 0 over 0, this is what we call indeterminate. We do not know what the answer is. So let's investigate a little bit of what's happening here. At first, I'm going to look at a graphical approach. Everybody agree that that's the graph of sine of x? Then I'm going to look at the red. The red, at least approximately, is the graph of x. There we go. What was that? Now, as x goes to infinity, what happens to the graph of x? What happens to this y value as x goes to infinity? Yeah, it goes to infinity. Look at the sine of x. As x goes to infinity, the outputs constantly go back and forth between what two values? 1 and -1. That's the behavior of that function. So you could say that if we were headed to infinity, you would get a really, really big number divided by either a positive number or a negative number. So it doesn't really hone in on anything as you're going to positive infinity. But as we're going to 0, as you look at it, this is kind of interesting. You can see that the sine of x value is going to 0, and obviously the x value for x is going to 0 as well. And the question is, what would that limit be if we simply divided those values? Well, what do you think? Do these values look like they're close together? So if you would divide them, what would you get? It would seem reasonable, wouldn't it? But let's try to verify and make sure. Let's look at a table of values. Take out your calculator. Make sure that your table is on. And I'm going to type in sine of x divided by x. And I'm going to go into my table set, and I'm going to go to my independent variable and do ask. And I'm going to look at my table. Now, in order for a limit to exist, it must be the same from the right and the left-hand side. So I'm going to approach 0. What's that? I plugged in sine of x over x. I'm going to approach from the right and the left. If I want to approach from the right, I'll plug in 1. What would be another value I could plug in after 1? I want to get close to 0. 0.1. Then what does it appear? Yeah, it's headed towards 1. If you actually plug in 0, it doesn't like it. It gets angry. Error. But it looks like it's headed towards 1. Everybody agree with that? Let's head to it from the left-hand side. So -1, -0.1, -0.01, and -0.001. And you can see it still seems to be headed towards. Would you agree that we are convinced that the limit is 1? Question. Suppose x was approaching pi over 2. Pi over 2 is 1.57. So I would plug in 1.6, 1.58, 1.575, 1.57, 5. Just come up with values that are close. You know what I mean? That would be from the right, then you got to do it from the left. Okay? So, here's what I have. Our table values confirm that it is in fact 1. And as we look at the graphical representation, we said that it looks like if you take the two values and divide them, you should get 1 because they look like they're about the same at that region. Well, L'Hopital came out with a great rule for this type of scenario. Given the following conditions, the limit as x goes to a of f of x is equal to the limit as x goes to a of g of x, which is equal to 0. So if both limits are equal to 0, or limit as x goes to a of f of x equals the limit as x goes to a of g of x is equal to positive or negative infinity. Got that? Then here's the idea. This is what you got to focus on. If we have a function on top and we have a function on the bottom, and you divide them and you get 0 over 0, or a function on top, function on the bottom, you divide them, you get infinity over infinity, or negative infinity over negative infinity, or infinity over negative infinity, or negative infinity over infinity. Those are what we call indeterminate values. Everybody okay with that? We don't know what those are. If you get that situation, then the following may be applied. You may take the limit as x goes to a of f prime of x over g prime of x. So if you come up with indeterminate values, then you can do the derivative over the derivative. This works out sweet. What is the derivative of sine of x? You just took the AP exam. What's the derivative of sine of x? Cosine. Thank you. Yeah. Yeah, same thing. The negative being on top or bottom doesn't matter. Okay, so derivative of sine of x is cosine of x. Derivative of x, 1. When we first plugged in 0, we got 0 over 0. Let's take the derivative of the top and bottom and plug 0 in again. What's cosine of 0? 1. And then 1 stays 1, and I get 1. Hey, look at that. Now I got an answer. Turns out that 0 divided by 0 is 1 in that situation. What it did is it compared the rates. The slope of this function is 1, and the slope of that function is 1. So it turns out that when you come up with indeterminate forms, say 0 over 0 or infinity over infinity, instead of comparing the function values, you can compare the rates at which they're going to that value. It comes out to be the same. That's awesome. Helps us do some amazing things in calculus as we move forward. But the indeterminate form must be in play, and I will show you more about that as we move along. So let's try some examples. Limit as x goes to 1 of natural log of x over 1 minus x. Anybody know what the natural log of 1 is? That means e to the what power is 1? 0. So we get 0 over, and 1 minus 1 is? That's 0, right? Do you know what 0 over 0 is? It's an indeterminate value. Oh no, what will we do? Well, thank you, L'Hopital, for coming up with a wonderful rule. Let's invoke it right now. What is the derivative of natural log of x? 1 over x. What's the derivative of 1 minus x? Negative 1. Can you plug in 1 now? Do it. Awesome. awesome. Right? Well, that's great. Look, 0 over 0 when we did our first example was 1. Now we did another example. We got negative 1. You don't know what you're going to come up with. You could come up with pi. Come up with square root of 2 minus 3. You don't know what you're going to get. Flip it over. That's it. Limit as x goes to infinity. Let's plug in infinity. What is e to the infinity power? All over infinity squared, which is infinity. Oh no, I don't know what infinity divided by infinity is. I wrote a song about it once. It was wonderful. And we said that some people will actually write what? Ah! Really? You can't do that. It's an indeterminate value. Don't you know L'Hopital's rule? So we do limit as x goes to infinity of, let's take the derivative of the top. Can you get? Isn't that beautiful? Divided by the derivative of the bottom, 2x. Let's plug it in. E to the infinity is infinity. 2 times infinity. Oh no, what should I do? Do it again. Derivative e to the x. Isn't that just wonderful? Derivative 2x. Dose. E to the infinity is infinity. Divided by 2. A very, very, very large number divided by 2 is still a... What is infinity? Even 10 times. Doesn't matter. But here's what does matter. If you don't come up with infinity over infinity, you can't apply L'Hopital's rule again. You cannot invoke L'Hopital's rule whenever you want. Well, in this situation, it wouldn't work. Watch what happens. What's the derivative of e to the x? E to the x, what's the derivative of 2? 0. Well, all of a sudden, what does that mean? Okay, and so we're going to come up with examples, and that's just one situation. But when you don't come up with indeterminate form, L'Hopital's rule does not apply. Okay, so, all right, let's try this one. What's the derivative natural log of 2x? What rule do you have to use to find that derivative? Well, I'm sorry. I just jumped to L'Hopital's rule, which is a mistake that people make all the time. I shouldn't do that. I have to verify whether or not it's indeterminate. I plug in infinity. What's the natural log of infinity? It is infinity. And if you're wondering about that, the graph of natural log looks like this. It does go to infinity. It takes a long time to get there, but it does get there. The cube root of x looks like this. So that also heads towards infinity. Do you know what infinity divided by infinity is? We don't. Last time it came up to be infinity. So we invoke L'Hopital's rule. As Colton said, we use the chain rule. We have the natural log of u, and we have 2x. Derivative of 2x is 2. What's the derivative of natural log of u? Over u. So I got 2 over 2x, which is 1 over x. So I've got the limit as x goes to infinity of 1 over x over... What is the derivative of x to the 1/3? 1/3 x to the negative 2/3. So that'll be 1 over 3x to the 2/3 power. Uh-oh, what should I do? Multiply by reciprocal times 3x to the 2/3 over 1. What do I have in the top? 3 over x to the 1/3. Good. So, got 3 in top. And infinity to the 1/3 power is still infinity. What is 3 over a very, 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 very large number? 0. You can see that in this situation we come up with 0 before we came up with infinity. You never know. That's why it's so fun. We got time for one more. Plug in 0. We get 0 minus, what's the sign of 0? Over 3 times 0 squared. Is that indeterminate? Yep. So we got the limit as x goes to 0 of, what's the derivative of x? 1 minus, what's the derivative sign? over derivative 3x squared. Plug in 0. What's the cosine of 0? 1. So you get. So what should we do? What's the derivative of 1? What's the derivative of negative cosine? Positive sine. What's the derivative of sine of x? Or 6x? What's the sine of 0? Go get some brain food. Come on back. We're almost done with the lesson. Okay, in this next example, we plug in pi. What's the sine of pi? 0 is correct because right over there you've got negative 1, 0 sine is the y value. So you've got 0 over, what's the cosine of pi? Negative 1, so you get 1 minus negative 1 is 2. So you get 0 over 2, which is 0. Is 0 over 2 an indeterminate form? No, it's not. And if you would try L'Hopital's rule in this situation, you wouldn't come up with 0. Okay? So in this situation, the answer is 0. You don't need to use L'Hopital's rule. Okay? I'll show you again with this one. Example 7, we plug in 1. We plug in 1, what do you get? Okay? 0 over 0, is that undefined? Or is that indeterminate? So invoke L'Hopital's rule. Limit as x goes to 1 of, what's the derivative of 14x to the fifth? 70x to the fourth over, what's the derivative of 6x to the fourth? So we plug in 1, and you get, which is 35 over 12. Now, I want to be clear that suppose you were like, you know what, we're just going to take the derivative again. And you got 140, 280x to the third over, you multiply that by 3, and you got 72x squared. 780 over 72 does not reduce to 35 over 12. So it doesn't work if you keep going unless you have indeterminate forms. Yes. I plug in 1. What's 1 to the fifth? Okay, example 8. E to the t. It should be t approaches 0, sorry. What do you get if you plug in 0? What's e to the 0? 1 minus 1 over 0 to the third. So I get 0 over 0. Is that indeterminate? Yeah, so do L'Hopital's rule. We have the limit as t goes to 0 of, what's e to the t derivative? Over. And we get 1 over 0. Is that indeterminate? No. We don't have undefined as an answer for limits. What do we have? We have the limit does not exist, but in order to determine that the limit does not exist, we'd have to check from the right and the left, correct? So you can't really get through this type of problem without looking at a graphical approach. So what we need to do is we need to consider the graph. So I'm going to go into y equals, I'm going to type in parentheses e to the x minus 1 divided by parentheses x to the third. And as I graph that, as I approach x from the left, what does the y value approach? Infinity. As I approach 0 from the right, what does the y value approach? Infinity, right? If I look at the table values and I approach 0, you can see that you're getting 1 times 10 to the 8th. You're getting very, very large numbers. As you punched in positive numbers, 1, 0.1, 0.01, 0.001. You can see again, you're getting significantly large numbers. So it approaches infinity from the left, and it approaches infinity from the right. So does the limit exist? Yes, it is infinity. Yes. We are in the green book now, and I'm not going to hand out all the green books, but I am going to give you a copy of those pages, okay? So your assignment's sitting right at the bottom. I'll bring that up later. I'm not ready for it right now, but that time will come. I got to verify that we're not going to do anything.